Hello everyone, and welcome back to my channel VST. Today we're going to dive deep into a crucial aspect of modern web applications, JWT Authentication with refresh tokens. Why this matters? This approach ensures better security, improved user experience, and prevents frequent logins while protecting against token theft. Before we dive into the code, I need to ask you something. If you're serious about building production-ready .NET applications, hit that subscribe button right now and turn on the bell notification. We're building real-world applications here, not just theory. And while you're at it, smash that like button and comment VS Part 4 below. Takes 2 seconds and I'll reply to every single one. Now let's build something amazing. This is Part 3 of Clean Architecture with dynamic role-based permissions in C#, and I'm excited to walk you through a production-ready implementation. I highly recommend to watch Part 1 and 2 before proceeding. This is the same project that we have been working with so far in this video series. First, we define our JWT configuration inside AppSettings.json and map it to strongly typed classes. Benefit: centralized configuration management, easy to modify without code changes. Why do we use this? To avoid hard-coding secrets and token settings, to support environment-based configurations, dev, QA, prod, principal/pattern used, options pattern, configuration pattern, single responsibility principal SRP. Here we set refresh token validity in days, set to 7 days. Token validity in minutes, set to 15 minutes. You can change it according to your need. To work with our configuration in a type-safe manner, we will create strongly typed classes that map to our JSON configuration. This ensures compile time safety and IntelliSense support. Why do we use this? To prevent runtime errors from string-based configuration and to improve maintainability. What design pattern is used? Options pattern, binding configuration sections to POCO classes for structured access. Here we define the refresh token entity, which represents a refresh token stored in the database with full lifecycle tracking. Inherit abstract base entity class. Now, we create token property, the actual refresh token string. We use private set in C# to enforce encapsulation and control over data modification. It means that anyone can read the value, but only the class itself can modify the value. Create expiry date property to check when this refresh token expires. Is revoked flag, indicating if this token has been revoked. Is used, flag indicating if this token has been used already. Once a refresh token is used to get a new access token, we mark it as used. Application user ID, foreign key relationship to the user. User, navigation property to the application user entity. Notice we have a private constructor. This is used by Entity Framework for materialization. This follows domain-driven design principles, where entities should be created through explicit methods, not directly by the caller. The isActive method is a simple but important helper that checks if a token is still valid. The revoke method allows us to invalidate a refresh token. Now, go to Application User and set all property setter as private so that entity controls its own state. Here we create a relationship property, refresh token. One user can have multiple tokens, multi-device login. Virtual enables lazy loading in Entity Framework. Domain-driven design with encapsulation used in refresh token class, keeping business rules within the entity. Let's configure our refresh tokens in the application DB context with proper indexes and constraints for optimal performance. What is DB set? A collection of entities in the database, provides CRUD operations, supports link queries, maps to database tables. Maps the refresh token entity to the refresh tokens table. Places the table inside the U schema, for example, u.refreshTokens, used to customize table name and organize database structures. Configures primary key using ID for the entity. defines property rules like required fields and max length constraints, creates a unique index on token to prevent duplicate tokens, adds an index on expiry date for faster query performance, ensures proper data validation and database optimization. The main benefit is unique index on tokens, prevents duplicates and improves lookup performance. Why do we use this? Ensures data integrity and fast token validation queries. To manage our settings elegantly, we create interface that defines our service contract. This interface provides 3 methods to access different parts of our configuration. Get AppSettings method returns the complete AppSetting object. Get JWT settings method returns only the JWT configuration. Get identity settings method returns only the identity configuration. Create a class AppSetting service and inherit AppSetting service interface. The main benefit is to decouple configuration access from implementation details. Why do we use this? Makes configuration accessible throughout the application while maintaining separation of concerns. Here we use service locator pattern with dependency injection, registers AppSetting service with its implementation. AppSetting service in the dependency injection container. Add. Scoped means a new instance is created per request and shared within that request. Used to inject the service wherever needed without manually creating objects. Create JWT Service interface to defines a contract for JWT-related operations like generating and validating tokens. Includes methods for creating access tokens and refresh tokens, and managing their lifecycle. Supports security features like token validation and revocation, helps keep authentication logic separate, testable, and maintainable. Create a class JWT Service and inherit JWT Service interface. Click on JWT Service interface and press Control key from the keyboard and dot to implement the interface methods. The main purpose of this class is to handle authentication using JWT. The constructor prepares all required services and settings so the class can perform JWT operations properly. It receives application DB context, AppSetting service, and logger through dependency injection. It assigns the database context to underscore context so the service can store and retrieve refresh tokens. It calls AppSetting, service.getJWT settings, parents to load JWT configuration, like secret key, expiry time, into underscore JWT settings. Here's how we generate secure access tokens with comprehensive claims including user roles and custom claims. Our comprehensive claim collection gathers user information, roles, and custom claims from multiple sources. Get user claims async method. Fetches all custom claims associated with the given user by using User Manager to retrieve claims from the database and returns the claims so they can be included in the JWT token. Get User Roles Async is used to retrieve the list of roles assigned to the user using Identity's User Manager. Get Roles Claim. Async is used to create a list of claims based on the user's roles and adds each role as a claim. Types.roleClaim for authorization checks. Uses Role Manager to fetch additional claims assigned to each role from the database. Then combines all role-based claims and returns them. To generate a JWT access token for the given user by first collecting all user-related claims. Creates a security key and signing credentials using the secret key and HMACSHA 256 algorithm. Builds the token with issuer, audience, claims, and expiration time from configuration. Finally, converts the token into a string that can be sent to the client for authentication. Validates the user ID and generates a secure random refresh token using a cryptographic generator. Creates a refresh token object with user ID, token value, expiry date, and IP address, and saves the refresh token to the database using Entity Framework. Logs the creation and returns the token for future authentication. Refresh flow. GetRefresh. Token async is used to fetches a refresh token from the database matching the given token value, and also includes the related user information using include for further use. Revoke refresh token. Async is used to retrieves the refresh token from the database and returns false if it doesn't exist, and marks the token as revoked, invalid, and saves the changes to the database. Logs the action and returns true to indicate successful revocation. Validate refresh. Token async method is used to check if the refresh token exists and is still active, not expired, used, or revoked, and returns whether it's valid along with the associated user ID if valid. Finally, we registers JWT Service with its implementation JWT Service class in the DI container. Add scoped ensures a new instance per request. Allows the service to be injected wherever needed in the application. Let's quickly recap what we built today. We started with configuration management using the options pattern, created a domain-driven refresh token entity, configured our database with EF Core for optimal performance, and implemented a production-ready JWT service with full token lifecycle management. Most importantly, we applied solid principles and design patterns throughout, making our code clean, maintainable, and scalable. Before you go, do the 3 things. Smash that like button if you learned something. Comment, learned below, takes 2 seconds. Subscribe for part 4 next week. I reply to every comment. See you in the next one.